Let's try another example of limiting reactants or limiting reagents, and this time let's explore what it means to have an excess amount. So this question is going to have two parts. Propane, C3H8, is used in gas barbecues and burns an oxygen gas to produce carbon dioxide and water. All right, so that's enough information to give us a balanced chemical equation. Propane, C3H8, plus burns an oxygen. So never just O. Oxygen is O2. Burns to create, and they were happy and helpful enough to produce carbon dioxide and water. Awesome. Is this equation balanced? Of course not. It's up to you. Easiest way of balancing a combustion equation like this is to start with carbon. There's 3 carbons, so we must make 3 carbon dioxides. 3 carbons, 3 carbons. 8 hydrogens, so I put a 4 here and now I have 8 hydrogens. On this side I have a total of 6 plus another 4, that's 10 oxygens, so 5 O2s will give me a balanced chemical equation. To do a limiting reaction question, I have 2 assumptions to test. If I use up all 100.7 grams of propane, how much, in this case I'm going to figure out, water would that make? And if I use all 380 grams of oxygen gas, how much water would I make? Those are my 2 questions, and that's what I'm going to figure out first. If C3H8 is the limiting reactant, and I'm going to get lazy and just write LR. Let's see. 100.7 grams of C3H8. I'm going to change grams of C3H8 to moles of C3H8 propane. So the molar mass of propane happens to be 44.11 grams. It's the same as 1 mole. So I've changed grams at this point to moles of propane. I'm not interested in moles of propane. I'm interested in water. So I'm going to use the balance coefficients to figure out how many moles of propane give me moles of water. In this case, 1 mole of propane give me 4 moles of water. And as long as I'm doing this, I really don't want moles of water. My head doesn't really think in moles. I don't have any tools in my lab to measure moles of water. I do have tools that take moles and give me grams of water. The molar mass of water happens to be 18.02 grams per mole. I put all that information into the calculator and I end up with an amazing 164.55 grams of water. Awesome. That assumes the limiting reagent is propane, C3H8. There's another option. Maybe oxygen runs out first. If propane, if gas in your barbecue runs out first, we'd end up with 164 grams of water. Let's see how much water we'd end up with if oxygen is the limiting reagent. So in oxygen, we don't start off with 100, we start off with 380 grams of O2. And again, we take mass and change it to moles with molar mass. 32 grams of oxygen make 1 mole of oxygen, gas. In this case, 5 moles of oxygen would be balanced against 4 moles of water. And then the same ratio is here. 18.02 grams of water is in 1 mole of H2O. Now let's figure that out. And calculator says 171.19 grams of H2O. You want to look for your lower number. This is our low, this is our high. So this is not true. This is our limiting reagent, and this is our mass of water. Therefore, limiting reagent is propane, and 164.55 grams of water is produced. Awesome. Same as the last example. Remember, always looking for the lower value here. The new part of the question is here. Calculate the amount of excess reagent that remains in solution, or in this case in the combustion. Alright, so how much do we have left over? We know that all of the propane gets used up. There is no leftover propane, but there is leftover oxygen. Another way of saying that is that we used up 100 grams of propane, but we didn't use 380 grams of oxygen. We used some other number of oxygen. If we could figure out how many grams of oxygen we actually used up, we would be able to figure out how much excess oxygen we had just from subtraction. If you go back to that trike example we looked at before, we said that 2 grips and 3 wheels in one frame made a trike, and since we had 45 wheels, we made 15 trikes. But we had 150 frames. Well, 15 trikes, how many frames did that use? Well, that only used 15 frames. So how many extra frames did we have? Well, we had 150 frames originally, minus the 15 frames we used. We have an excess 135 frames. We're going to do the same idea. In this case, what we're really asking is how much oxygen is used to react with, and we were told 100.7 grams of C3H8. All right, well, that's a calculation we can do. We start with our mass that we were given, 100.7 grams of C3H8, and grams always have to go to moles. So do I have to do this molar mass calculation again? No, I've already done it. I know that it's 44.11 grams of C3H8. Give me 1 mole of propane. And now I'm going to change moles of propane. Now I have to think about this. I want O2. So I want moles of O2. I have to go back up to my balanced chemical equation when I've got 2 different chemicals here. 1 mole of propane is combined with 5 moles of oxygen. 1 mole of propane, 5 moles of oxygen. Moles of oxygen. And really I want grams of oxygen. So what's the combination there? We've used it over here. Molar mass of oxygen gas is 32 for 1 mole. So if I do that calculation, when I use up all of my propane, I end up with a total of 356.27 grams of O2 is, we say, consumed. I didn't ask what is consumed. I want to know that remains. I had originally 380 grams of oxygen. My 380 original grams subtracted from my 356 gives me a total of about 14 or 15, 14.73 grams extra. Calculate the amount of excess reagent. O2 is the excess, and we have 14 or 15 grams of excess.